In this example, we're going to take a look at solving this radical equation. And probably the first thing you notice right away is on the left side we have a square root, while on the right side we have a cube root. Well, one good thing is that there are no terms outside of the radical expressions. So if you'd like to try this problem on your own first, go ahead and pause the video and do so, and then come on back and we'll work a couple of different solutions together. All right, so we're going to do this two different ways, and the first way is going to be using a U-substitution. So I'm going to take that entire left side of the equation, and I'm going to say U equals, so we'll have the square root of x plus 4. Okay, well that's really easy here because the left side just becomes U. Well, how about this right side? Well, it looks like we'll have the cube root of, well, we need to take this 7x minus 8 and write it in terms of u also. So we'll start by using our u equals, and we're going to square both sides. So u squared equals that x plus 4, and then we can subtract 4 from both sides. So we'll see that u squared minus 4 equals our x value right here. So when I plug this in, it'll be the cube root of 7 times x, which is u squared minus 4, and then minus 8. So we can now say u equals the cubed root of, it looks like 7u squared, and then 7 times negative 4 is negative 28, minus 8 more will be negative 36. Okay, so here's what we have, and now instead of two radicals, we have just the one radical. So let's cube both sides in order to get rid of this cube root. So on the right, the cube and the cube root cancel. So we're left with u cubed equals, and it looks like 7u squared minus 36. Well, this seems like a nice polynomial equation. It'll be a cubic equation. So let's go ahead and move all these terms to one side and set it equal to 0. So u cubed minus 7u squared plus 36 equals to 0. Okay, so when we solve for u here, we'll have maybe upwards of 3 values here, and then we'll just plug them right back into here and solve for x, and we'll have our possible values, and of course we'll have to check them to see if any of those are extraneous. Okay, so looking at this, it seems like the rational root theorem would be a pretty good way to go. It looks like plus or minus 1 won't work. Plus or minus 2, let's try a negative 2. So let's use synthetic division on the negative 2. So we have a 1 and a negative 7 and a 0 and a 36. We bring a 1 down, that multiplication, the addition, the multiplication, the addition, and the multiplication. And yeah, that worked out okay. So our remainder here was 0. So we know that u plus 2 is one of the roots, and then we have u squared minus 9u plus 18, which will factor very nicely. So u plus 2, and then it looks like u minus 3 and u minus 6. So we have 3 great looking values, negative 2, positive 3, and positive 6 for values for u. But of course those are u values and not x values. So recall that x equaled u squared minus 4. So if x equals u squared minus 4, let's go ahead and plug these back in one at a time. So u equals negative 2. So that will mean that x equals, well, negative 2 squared is 4. 4 minus 4 is 0. So u equals 3. So x will equal 3 squared is 9 minus 4 is 5. And finally, u equals 6. And 6 squared is 36 minus 4 is 32. So it seems like we have 3 possible values for x. 0, 5, and 32. So let's go ahead and plug them back into our original equation. And I'll just go ahead and rewrite this original equation. Okay, and we'll see what works and what doesn't. So we'll plug 0 in first. So 0 plus 4 is, well, 4. Square root of that is 2. So I'll have, and this is x equals 0. So 2 equals, and then 0 times 7 is 0 minus 8. Cube root of negative 8 is negative 2. So 2 equals negative 2. That's no good. So that'll be an extraneous solution. So let's try x equals 5. So 5 plus 4 is 9. Square root of that is 3. 7 times 5 is 35, minus 8 is 27, cube root is 3, so 3 equals 3. So 5 is good to go. So let's try this final one. X equals 32. So 32 plus 4 is 36, square root is 6. And then let's see, 32 times 7 minus 8. Let's see, 224 minus 8, 216. Cube root of 216 is 6. So it looks like we have two solutions here. X equals 5 and 32. So these two solutions are the x values that will make this radical equation true. Okay, so that's one way to go about solving this, is by using a U-substitution. And you saw we got rid of one of the radicals that way, and then we cubed both sides. We had a nice polynomial. We were able to factor very nicely. We put our values from u back into terms of x, and we checked them, and here we go. So let's try a second way to go about solving this equation. So in this second method, what I'm going to do is turn each of these radical expressions into rational exponents and deal with it that way. So the square root will become, we have x plus 4 to the power of 1/2, and this cube root, of course, will become to the power of 1/3. And taking a look specifically at these fractions, the denominators are 2 and 3. So the least common denominator there is going to be 6. So what I'm going to do is raise each side of this equation to the power of 6. And what that's going to do is employ the power of a power property for exponents. And 1/2 of 6 is 3, so we'll have x plus 4 cubed equals, and then 1/3 of 6 is 2. So we now have this equation. So instead of a couple of radicals, now we have a couple of, well, higher powers. So let's go ahead and multiply all these out and see what we have. So when we cube something, we're really going to take it and multiply it by its square. So I'll just go ahead and square it there, and then we can finish this multiplication out by using a series of distributions, of course. Okay, so on that left side we have x cubed plus 12x squared plus 48x plus 64 equals. And when we square this, it'll be, let's see, 49x squared minus 112x plus 64. Well, there's lots of terms there, but it is nice because the positive 64s will cancel. So we can just bring these two terms over, subtract 49x squared from both sides, and then add 112x to both sides in order to get a little polynomial equation here. So x cubed minus, and it looks like 37x squared, and plus 160x equals 0. Okay, well, all these terms have x's, so let's factor that greatest common factor out. And then it looks like we can factor this. So what two numbers multiply to make 160? That add to make negative 37. And it looks like negative 32 and negative 5. And those numbers are familiar. So we can use the multiplication property here of 0, which says if all these get multiplied together to give us 0, well, it's because one of these had to be 0. So we'll account for all of them, and we'll just set each of these factors equal to 0. And so I'll have x equals 0, 5, and 32. And those numbers are very familiar. We know that the 0 is an extraneous solution, and we found that earlier. So 5 and 32 were the other two values that worked. So we're done, and here is just a second way to go about solving an equation like that. We changed our radicals to rational exponents, and we found the least common denominator here, raising each side of the equation to that power. We ended up with a little larger polynomial here, but that's okay. It worked out and factored nicely and still gave us these same solutions.